very good morning to all. I am Priti Choudhary from Akgec Engineering College. Here I am working as a assistant professor in IT department. So today I will discuss about fifth unit of data structure, that is graph. So in this session I will discuss about what is graph and graph data structure, types of data structure and graph terminology. So these are some topics which are covered today in this session. First one is terminology used with graph, data structure for graph representation, types of two types. First one is adjacenting matrix and third one is adjacenting linked list. Third point is graph traversal. Graph traversal also classified into two types, DFS and BFS. DFS means depth first search and BFS means breadth first search. After that I will discuss about the connected component and spanning tree. Next one is minimum cost spanning tree, means MST, and also the example of MST is Prim's and Kruskal algorithm. And last topic of this unit is the transitive closure shortest path algorithm, and example of shortest path algorithm is Floyd-Warshall and Dijkstra algorithm. So these topics are covered in this unit, and today I will discuss about only terminology used with graph, data structure, graph representation and types, graph representation, matrix types and linked list type. So start the first topic is graph. The first one is data structure is what? Data structure is use the way and manage the way to store your data in your system. So there are the different types of data structure which already discussed in previous session. So this is the last unit of data structure. First one is the graph. Graph here. What is the graph? The data structure also classified into two types, linear and non-linear. And in linear data structure, we have already discussed about array, stack, queue, linked list and all. So there the graph, it is the non-linear data structure, graph and tree. Both are the non-linear data structure. Here data is stored as a randomly form. So a graph is a non-linear data structure, consists of a vertex, number of vertex and number of edges, and the vertex are sometimes also referred to a node of, and edges are the referred to a line and connected line between two nodes. And morally here if I want to use this as in this way, and graph is composed the set of number of vertex and number of edges. So here we can also denote by this form. G is stand for a graph, and here E is stand for a number of edges in given graph, and V is the number of vertex of this given graph. So these are the graph form. So also denoted by graph in this way. So here according to this, two component include in this graph form. Two component, edges and vertex. So component, or also we can say that it is also component of graph. So here the two component, first one is vertex and second one is edges. Okay. So what is a vertex? Vertex are the fundamental unit of graph. Sometimes vertex also known as a vertex, also known as a node. Every node and vertex can be labeled and unlabeled. It means it defined of maybe it is A, B alphabetically labels, and it also defined numerically labeled. And next one is the edges. What is the edge? Edge are the draw used are connected to nodes of the graph. Like here in a given graph, let's suppose this is a graph or two nodes are present in this graph. So connected line A to B is called the edges. Okay, or it may be labeled or unlabeled. Next one is graph. As I discussed in my previous slide, graph is defined as this symbol, graph equal to V equal to E. V is a vertex and E is a edges. So V the vertex, like in a given graph have many types of vertex, like 1 2 3 4 5. So it is the combination, it is the number of vertex, and edges is also same number of number of edges in a given graph, E1 E2 E3 E4 at least so on En. So they are the some different types of graph. So according to this is a simple graph here. According to this graph, totally this is a direct this is a simple graph. According to this, 1 2 3 4 5, number of 5. The vertex value is 5 here, and edges value is 1 2 3 4 1 2 3 4 5 6 7. So edges is 7. So symbol of this graph is 5 into 7. Got it? So also further discuss of this graph is types of graph. So here, according to this is simple graph. Now comes to here this graph. This is a undirected graph, means here no direction given on edges, like this. So this is called a undirected graph. You can move 8 to 9 and you can move 9 to 8 because there no direction is given. So you can move here and you can go any node in this graph. But in a direction, edges have some weighted, like 1 2 3, like any amount, any weight, like this. So this is called a weighted graph. Next one is null graph, trivial graph, undirected graph, directed graph. Directed, undirected already discussed. And null graph is means here all number of vertex are not connected to each other. According to this, there are the 4 vertex, and the 4 all vertex means here no any edges in this graph. So there are no edges in this graph is called a null graph. So any node to another node, so this is a null graph. Next one is the trivial graph. According to trivial graph, having a single vertex, it is also called a smallest graph. Like suppose here, according to this is 2. According to this, only there one vertex, no edges and no any other vertex, so called a trivial graph, and also called is isolated graph. Isolated graph is also a single vertex in a graph, and it is called a smallest graph also. Next one is undirected graph. Undirected graph is same as I discussed in my previous slide. A graph in which edge don't have any direction is called a undirected graph. And directed graph, a graph in which edges has a direction. These are some other types. Fifth one is the connected graph. Connected graph means according to diagram, this one, according to diagram, the graph in which from one node can visit any other node in a graph is not a connected graph. It means if you want to move any vertex in given graph, then you can easily move, then it's called a connected graph. Let's suppose if you want to go vertex on vertex 3. So if you have destination point is this and you want to move here, so then you just pass 5 to 3. So this is called a connected graph. Now come to the disconnected graph. Disconnected graph, the graph in which at least one node is not reachable from one node to another node, it is called a disconnected graph. Let's suppose the next is according to this diagram. Here you can move 3 to 5 easily and 5 to 3, but if you want to move 3 to 4, so you can't. So this is called a disconnected graph. Next one is regular graph. Regular graph, the graph in which the degree of every vertex is equal of k is called a regular graph. According to diagram, see here, this is a regular graph, means have same degree. 3 have 2 degree, 1 have also 2 degree, 4 have also 2 degree, and 5 have also 2 degree. It means all vertex have same degree. Let's suppose what is degree here? Degree is number of edges connected to vertex in this undirected graph. Okay, so 3 have connected 2 vertex, 2 edges called a 2 degree. 1 have same 2 edges connected, so also called a 2 degree. 4 have 2 edges connected, so 4 have 2 degree. 5 have 2 connected, 5 have 2 edges connected, so also called a 5 have 2 degree. So regular graph means the graph in which the degree of every vertex is equal. 2, 2, 2, 2. So in this types of graph is called a regular graph. or here 2 it means degree 2. Okay, now comes to the next graph types, that is complete graph. According to complete graph, the graph in which from each node there an edge is to connected another edge. Here according to this, if you see regular graph, then there is no connection 3 to 4, but you see in next complete graph, here connected direct connection to each other, direct connection. If you want to go 3 to 1, then you can move directly 3 to 1, 3 to 1. If you want to move any vertex of this from 3, then you can directly, you can move 4, directly you can move 3, 5, and same thing again 5, easily move 3, 5 easily move 1, and 5 easily move 4. So same means all vertex means each vertex, their edges each other connected to each other node. A graph vertex is number of edges. If a complete graph, if you have complete graph, the number of edges is this, and n minus 1 divided by 2 edges. Okay, next types of graph is cycle graph and cyclic graph. They are the one difference between the cycle graph and cyclic graph. Cycle graph, the graph in which in a cycle itself the degree of each vertex is 2. Let's suppose we send here only the one cycle here. Okay, in this graph only one cycle and each node have same degree. But comes to the next graph, it's cyclic graph. Cyclic graph, a graph connected at least one cycle, known as a cyclic graph. Here also same vertex 1, 2, 1, 3, 4 and 5. But according to this, here only one cycle occur in whole graph. Got it? Now comes to the directed acyclic graph. Directed acyclic graph, here same thing. Directed graph does not any cycle and direction also given in this graph. So same thing, directed graph that does not contain any cycle. यहाँ पे हमारी कोई cycle नहीं बन रही. If you want to move this, then you can't move this. Again here you can't move here. So there according to this and not any cycle present in this graph is called a directed acyclic graph. Next one is bipartite graph. Bipartite graph is a graph in which vertex can divided into two set. Like according to this, the vertex also divided into two different set, and such that the that vertex in does not contain edges between to them. Let's suppose we take the example here. This is the bipartite graph according to this diagram. Here two all vertex are different and these are connected to one set to another set vertex. Got it? Next one is weighted graph. Weighted graph also discussed in my previous diagram like here. So this is a weighted graph. Okay. A graph in which the edge are already specify the suitable weight is called a weighted graph. Okay. Now comes to the some difference between in a tree versus graph. Tree are the restricted types of graph. Just some more rules. Every tree will always be a graph, but not all graph will be tree. Just because graph have cycle and tree have not a cycle. So we can say that every tree will always be a graph, but not all graph will be tree. Linked list, tree and heap all are the special cases of graph. Now comes to the find out the path. Ki what is path? Here path, a path from vertex 1 to another vertex. If you want to move source to destination and check the number of edges required in this way. Let's suppose you want to move A to D. So how many edges are required? Move to A to A. Here A to B, B to D and D to A. So how many required edges? 3. 1, 2 and 3. So path of this A to A direction cycle is length is 1, 2, 3, matlab total length is 3. Same thing A, B, C, D. So again A to B 1 edges, B to C again 1, C to D and D to A. So 1, 2, 3, 4. The number of length of this graph is 4. Now comes to next, degree of vertex. What is the degree of vertex? The total number of edges linked list to a vertex is called a degree. It means number of edges are connected, linked with vertex is called a degree. But degree also classified into two types. First one is in degree and second one is out degree. So what is the in degree and what is out degree? According to this, let's suppose we take the directed graph here. This one is a graph. Okay. Let's suppose give us some direction like this. Now find out the how many in degree in this graph and how many out degree in this graph. So according to this, out degree means out direction from a vertex. Out direction here 1, 2, here again out 4, 3, 4, sorry 1, 2 and 3. So this vertex have 3 degree, but out degree is of this vertex is 3. But check in degree, no, तो 0 हो गई in degree. Same, check again 3. 3 have how many out degree and how many in degree from this vertex? Out degree is 1. Only one connected line is 1, 2, 3 and check is out degree 1 and in degree is 2. So this is out degree of this vertex and this is in degree of this vertex. Okay. So in this way we can easily find out the degree of graph and easily find out the in degree of graph and out degree of graph. Now representative of graph. So there is a if you have graph, according to this is a graph have 4 vertex and these vertex are connected by different types of edges E1, E2, E3, E4, E5 or E6. This is a V1, V2, V3 and V4. So this is a graph and now I want to this graph implemented in our system. Then how? So these are the two types of representation. First one is sequential representation. Sequential representation means adjacenting matrix representation. Matrix means 2D array representation in our system. And second one representation is linked list. Here the connected using linked list. It means here two vertex are connected and it is stored in a different types of vertex. Okay? So different types of matrix and matrix is 2D matrix or here we use linked list representation easily. In a sequential representation, an adjacenting matrix is used to store the graph, whereas the linked list representation there are the two types of representation used to store data. Okay. Now comes to the sequential. Same thing. Sequential have 2D. Here the adjacenting I and J. Now comes to check the using this form. Here this is a undirected graph and check is because it is the first one representation is matrix representation. According to this undirected graph, in undirected graph means you can easily move source to destination and destination to source, means one node to second node and second node to one node you can move. So here if you have directed connection from one node to another node, then it will indicate by 1, and if you have not directed connection, means if you move one direction to one vertex to second destination vertex and using another vertex is indicate by 0. So this is the simple So according to this undirected graph, here A to B you can directly move. So A to B indicate by 1, and same A to C you cannot directly movement is, if you want to move A to C, then you use the in between node is B. So you cannot directly move. So A to C value is 0. A to C is value is 0. So in this way you can fill this matrix, and same thing occur, this matrix is filled by the undirected graph according to this, or here the adjacenting matrix, and but their data is filled by directed graph. So same thing here, if you directly move A to B according to this, you can move A to B directly. So E to B directly, then it is 1. So you can't move A to D here according to this, then you cannot indicate by 1, here indicate by 0. So in this way, first one is undirected graph matrix adjacent matrix representation, and second one directed graph, and third one is weighted graph. Here just indicate by 0 and 1 because there is no any weighted graph is present. But according to this graph, here graph matlab value, some value have present. So use, if you have direct connection A to B, but here A to B direct connection it is indicate by 1, but here not, here connection A to B, but weightage is 4. So you can write weightage 4. So in this session I will discuss just about the representation of graph using matrix. So in my next lecture I will discuss about the representation of matrix, representation of graph using linked list. So this time is, thank you so much.